Hello, my name is Ullas. I usually make watch repair and clock repair videos on YouTube, but today I'm just going to try something different and I'm going to build a clock, Fibonacci clock, uh, uh, and I'll be making a video on how I'm going to design it and how I'm going to build it. So before I start with anything, I'd just like to thank everyone for the wonderful response I've got for my previous videos. So I've got 35,000 views on my HES clock repair video, as well as about 8,000 on my HMT repair videos. And I've got 300 subscribers as well. It's crossed 300 now. One person that I'd like to remember at this point is Mr. Prashant Pandey sir, who was the one who asked me to make YouTube videos in the first place. That's when I made the first HMT video. Unfortunately, he's no longer with us. He passed away a couple of months ago, and that's a very sad thing. And I'd just like to remember him at this point. And I must apologize for not making any videos, any new clock repair videos or watch repair videos. I've been getting a lot of doubts about the HMT videos. They're outdated, and I have recorded a new version, but I was unfortunately not able to edit it and do the voiceover and upload it. That One of the main reason is because I was doing my post graduation at NIT Calicut. I was doing my MTech, and for that reason, I've not been able to work on anything so far. I've just completed it, so I've got some free time, and also I am not a huge fan of doing voiceovers, and that's one of the reasons I've recorded this video with live voice. And also the other thing is that like I had bought a tripod to make better videos, but along with most of my other luggage, it's at Kozhikode, Kerala, where I was studying at NIT Calicut. Because of COVID, I had to travel back by flight and I had to leave my luggage behind. And I will make more videos. I will try to make different videos like this one. I have different interests, so I'd like to explore all of it and also have better equipment to make videos probably. In this video, I'll be discussing about how I designed and built the Fibonacci clock. Uh, uh, my apologies if my pronunciation is not correct or if it's not accurate throughout the video, because I've been doing the live voiceover. And a Fibonacci clock, I'll be explaining what Fibonacci numbers are and what Fibonacci series is and what a Fibonacci spiral is and how this clock works basically. These are available online. I've seen them available online, but when I checked now, it was not up for sale. And usually they charge quite high amounts. So I never wanted to buy one. I had seen this and I had seen a hyperbola clock and so on. And I wanted to make all those. So this was the easiest one. So I decided to try this first. I had some of the parts lying around, and for that reason, I decided to just try this once. And I was able to build it in a budget of around 100 rupees. I'll be putting the proper amount later in the video. And that's about it. And what I'm going to do is I'll be dividing this video into three parts. So in the first part, in the first two videos, we'll be seeing what exactly a Fibonacci series is and what a Fibonacci spiral is, and how we'll be designing this. So I'll be using the NXTen software to design this clock, and I'll be taking printouts and building it with cardboard. So don't worry if you don't, if you're not a fan of designing something, or if you're not comfortable with any design softwares, then I'll be uploading a PDF with the third video, which you can download and directly take printouts and build it. So I think I can conservatively say you can build a clock in around 1 to 2 hours if you have all the materials lying around. I took more than that because this was my first attempt. To be honest, learned along the way because this is the first time I'm building this thing. I have built different kinds of watches, or clocks rather, which I'll be talking about probably in some future video. But like this is the first time I built this Fibonacci clock, and there was a lot of challenges that I faced along the way. So I would request you to watch the video till the end and make sure you listen to the mistakes that I've made and make sure you don't commit the same mistakes. So in fact, the spiral that will be the hour hand, I had to do it 3 times. I had to build it 3 times. So just don't make such mistakes, and just make sure that you just watch the video completely. Just form your own opinion on what is the right approach and probably build it. And other than that, yeah, that's mostly it. So I have more ideas in mind, the more types of clocks that I want to build, the more watches that I repair. I want to make videos on that. Also on my other interests, I'm very much interested in aviation and so on. But right now I'm looking for a job. So when I get the time, I'll probably make more videos. So I request you to enjoy the video. Just if you're interested in design, please watch the first two videos as well. If you're not, just you can watch the final video. I'll be probably putting the same introduction in all three videos. But enjoy the video, and I hope you build a Fibonacci clock. And if possible, please do post it. And also one more thing is, if you're interested in my work, I'll be putting my social media handles. Please do follow me as well, so you can see any other work that I won't be giving a video on. So and if you do build the Fibonacci clock, please do either on WhatsApp or Instagram. Please do send me the pictures of what you built. Thank you. Before we move any further, let us first try to understand what exactly is a Fibonacci series. So a Fibonacci series is an infinite mathematical series wherein we first start with the number 0 and then with the number 1. So because 0 itself cannot generate a series. Now after this point, what we do is we add the present number to the previous number. So here 1 is our present number and then 0 is our previous number, and 1 plus 0 will give us 1. But after this, our present number will be 1 and the previous number will be again 1. So 1 plus 1 will give us 2, and then once we add our present number, which is 2, to our previous number, which is 1, we'll get the number 3. In the same way, if I add 3 to 2, I'll get 5, and then 5 to 3, I'll get 8, 8 to 5, I'll get 13, and so on. So for most of our intents and purposes, we are not going to consider this 0. So let us assume that the Fibonacci series is starting from 1, and it's an infinite series, as I said, so it just goes on. So this series, it can be represented in the form of a curve. So how we'll draw the curve, let's come to that. But I've just googled the Fibonacci curve, and you can see there are a lot of representations which indicate how the Fibonacci curve looks. And this Fibonacci curve is what is used as the base for the Fibonacci clock. So again, I've googled the Fibonacci clock, and I've got a lot of images which I can keep as a reference for this particular work. So this, you can see that the spiral, what we'll get, the Fibonacci spiral or the Fibonacci curve, so that will be the hour hand of a clock. So how exactly we're going to draw that, we'll come to that. So the software that I'm going to use for this purpose is NX10. So NX10 is a CAD software. You can use any other CAD software like SolidWorks, Solid Edge, or CATIA, whatever is available. Or if any of those softwares are not available to you, or you're not familiar with them, you can probably just use a white sheet and a compass, pencil, scale, and I think you can get the same results. So since I'm quite comfortable with NX10, I'll be using that. So I'll click on New, and then I'll make sure that the folder is selected properly. And the first thing that I'm going to work on is the hour hand. So before that, I should select the model here. I should select model here, and then I'll give the name as hour hand, because that's the first thing that I'm going to work on. And I'll hit OK. After this, we'll have to draw the Fibonacci curve, because that is what is going to be our hour hand. So first we'll have to select a plane. So I'll go to Sketch. Then I'll select this vertical plane here, the YZ plane, and hit OK. So I'd like to have a kind of an outline of the clock dial. So after the hour hand, we'll have to make the clock dial, but just as a reference, I'd like to have an outline of the clock dial now itself. So for that reason, I'm going to draw the outline of the clock dial. So here I'll take the rectangle tool, and then I'll select the centered rectangle, or from center as it's called as here. And then I'll click the origin, that will be my center, and I'll draw a rectangle. Now the dimensions of this rectangle, you can actually choose it based on trial and error. Now the main important thing what we are going to fit here is the clock movement, which will be somewhere in around here. So the clock movement, the standard quartz clock movement, is a perfect square, and it measures at around 56.4 millimeters by 56.4 millimeters. So we can, so initially I assumed the width to be just a bit larger than that 56 millimeters, so I assumed it to be 80 millimeters, and then the height I assumed it to be about 3 times the height of this clock, which will be which approximately I took it as 180 millimeters, but that was not sufficient. That's what I found out later. So for that reason, the dimensions I'm going with is 270 millimeters by 100 millimeters. So we'll see that it makes a kind of a good rectangle here. So this will be our clock dial dimensions, but we are not making the clock dial right now. So I'd like to just click on all these lines and then convert them as references. So I'm keeping that only as a reference. And after that, we can start drawing our Fibonacci curve. I beg your pardon if I pronounce it wrong at any point. So the next thing we're going to draw is a base rectangle. I'll like to call it as a base rectangle. And for that, I'll take the rectangle tool again, and then I'll select by 2 points this time, not the from center. I'm selecting by 2 points. So I'll again take the origin as my first point, and then I'm going to draw a rectangle. Now, initially when I tried it, as I said, I've done some trial and error. I've already tried it once. So then I took 10 millimeters as the dimensions of the square, but I found that it was creating a curve which was too large. So I again changed it to 5 millimeters. So I'll be taking 5 millimeters by 5 millimeters as the dimension of this curve. This rectangle. And once the first square is done, I'll like draw an exactly identical square to the other side of the origin, and this will again be 5 millimeters by 5 millimeters exactly. So you may ask exactly why I'm drawing two identical squares. So if we go to the Fibonacci sequence, what we discussed earlier, the first one is 1 and the second number is also 1. So these two are the identical squares what we are drawing. So exactly what it means, let's come to it again. So here 5 millimeter by 5 millimeter, I have two squares. And then here we have to understand that I'm following a kind of an anti-clockwise or counterclockwise sequence, a counterclockwise curve. That's what I'm trying to make. So the curve will start at this point and then it takes the anti-clockwise or counterclockwise direction. So the next square what I have to draw will be here. So if I'm going for a clockwise curve, so then in that case I would have got a curve from here to here, and then I would have drawn the next square up in the upward direction. So since I'm going for a counterclockwise curve, I'm going to draw the next square in the downward direction here. So I'll take the square tool again, and the first point will be this, the end point, and then I'm going to draw a square here. So you can see that this square, the width of the square will be the total width of these two squares together. So that will be 10 millimeters because we had two squares of 5 millimeters each. Now I'm going for a 10 millimeter by 10 millimeter square. So that will be my third square. So this in our Fibonacci sequence, this will be our third number 2. So this, if I assume this to be 5 millimeter and 5 millimeter, the sum of these two will be 10 millimeters, which is this side we're getting for the square. So now the next square will be here again. So going in the counterclockwise sense, the next square will be here. So I'll take this point as my first point, and then I'll select my second point somewhere in around here, and then the total size will be, so we had 10 and previous to that we had 5, so 10 plus 5 will be 15, and even this dimension will be 15. So we have a 15 by 15 square, and once we have that, I have 4 squares in total now. So from my initial trials, I know that I have to make 8 squares. So I'm done with 4. So I'll take the next square in this particular point, and that will be 15 plus 10, so 25 by 25. And then the next square will be here. So yeah, and it will start from here, then go till there. This time it will be 25 plus 15, which will be 40. So you can see that the constraints, the automatic constraints of the NX software will already give those dimensions nearly to the point, to the value what we want. Because those points are snapping to the points that I'm trying to align it with. And I have now 1, 2, 3, 4, 5, 6 squares. So I'll draw the 7th one here. And then this will be 65. You can see it's already 65 here by 65. And I'll draw the last one here. So this will be 105 cross 105. So these squares what I have, so that completes the 8th square if I'm not wrong. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So these squares what I have, this will indicate the Fibonacci sequence. So I have to draw a curve using these squares. So to do that, I'll first hit on the finish. So you can see the kind of the arrangement of squares what we have. I'll just hide this origin. So I'll go to view and hide and hit coordinate system. So you can see the sequence of squares what I have here. And the next step what I'm going to do is to draw the curve. So I could have drawn it on the same sketch itself, but I don't want to make it clumsy. So I'd like to draw it on a different sketch. So I need my coordinate systems back. Go to home, sketch, and then I'll select this particular plane. And here again, here I have to start drawing the curve. As I said, I want it in a counterclockwise sense. So this will be my first point. If this is the origin, if I imagine that I'm holding a compass with the center here and the pencil here, so I'll be drawing a curve from here to here and then from here to here. And then once I come here, my compass center will be shifted from here to this particular point, and then this curve will continue here. So we have to shift the center of the compass in such a way that the curve continues in the counterclockwise sense. So again, once I come here, the center of the compass will get here, and then from here to here I can draw another curve. So what I mean is, so if this is the compass, so this arc, first I'll select the arc, and then I'll select arc by center and end points. So this is similar to how we use a compass, and I'll select the center as the origin, and then I'll take this end point and I'll draw an arc. So I can draw a complete arc, but just for the purpose of demonstration I'm just splitting it into 2 arcs. So I'll take the center again, I'll take this as the end point, I'll draw another arc here. Now after that I'm going to take I'm going to take this as my next center. I'll select this as my end point and continue the arc till it touches the end point here. After that I'll take this as my center, I'll select this as one of my endpoints, then I'll draw it till this endpoint, and here I take this as my endpoint, this is the other endpoint, that is the center, and this is the endpoint, and then I'll draw another arc. And after that I'll take this as my center, this as my other endpoint, and I'll draw an arc. I'll take this as my center, this as my other endpoint, draw an arc, this as my center, this as my other endpoint, draw the final arc. So as I said, this is an infinite series. The Fibonacci series is an infinite series. In the same way, this curve can go in an infinite way. This can just keep on going and going, but for our purpose, this is the curve what we want. So I have the Fibonacci curve now. Again, I can I think I'll do it here itself. So I have the curve right now. So the next thing what I am going to do is I have to give it a width. So what I have here, we can call it as the center line of our hand, because we cannot have just a straight line, just a line as an R hand. We need some thickness to it. So for that purpose, what I'm going to do is I'm going to take the offset option here, offset curve, and then I need a 4 mm wide thick hand. That's what I'm planning. So it will be 2 mm on either end. So I'll keep 2 as the number here, and make sure symmetric offset is selected, and under settings select convert input curves to reference, so that this line will be automatically converted into a reference line. So I'll select this curve. Now if I've selected connected curves, all curves, should automatically get selected. So once that is done, I'll hit on OK, and you can see that our original curve is now a reference line. So with that, what I can do is I can first close the end. So I'm just planning to close it with a kind of a circle or a semicircle. Take that as the center and just draw a semicircle. Once that's done, we'll come to the center. So here I need a point where I can attach the R hand to the movement. So for that, I'm going for a circle. So again, from my initial trials, I found that this circle should be around 30 millimeters. So I'll give this dimension as 30 millimeters, and I need one more cutout here. So before that, what I'm going to do is I'm going to clear the curve that is extending inside this circle. So from here, I'm going to just trim these curves. Also, I need one continuous loop, so I don't want anything in between, so I'm going to trim that off as well. So once I have a complete curve, I need a kind of a hole punched in the middle. So for that, I'm going to select this point again and draw another circle. And this circle, so for the dimension of that, if I measure the dimension of the post onto which the R hand sits, it's 5.6 millimeters in diameter. So I'm going to, I need a kind of a tighter fit. So for that, to achieve an interference fit, I'm going to go for 5.5 millimeters. Now, we are not going to make these holes in an exact fashion because we'll be cutting it with a knife or something. So for that reason, I'm just keeping it at 5.5 and hit finish. So once that's done, we have our sketch ready and we have to extrude it. Extrusion is not really required because anyway, I'm going to take a printout and paste it onto a cardboard and cut the cardboard. So I don't know the thickness of the cardboard exactly, but just for the purpose of demonstration, I'm going to give a thickness of 2 millimeters. So I'm going for symmetric offset and keep this value as 1. So that will be a total of 2 millimeters. Hit OK. And that will be our R's hand. So if I just go to view and then hide all the sketches, and also the coordinate system, we can see the R hand. Now, before we move any further, I noticed a few issues here. The thing is that this transition between the curve and the spiral, it's very sharp. So here I want this to be much more smoother. The main reason is that now if we have that kind of a sharp edge, it's probably a bit difficult to cut once we transfer it onto the cardboard. And the other thing is that this edge is going to be weak. That's what I feel. If it is weak, then there is a probability of breakage or bending at this point. So for that, I tried adding fillets, but that didn't work. So I'll directly go into the sketch itself, and I'm going to add a set of tangential curves. So I'll take the curve here. I'll select the arc by 3 points. I'll select a random point here. I'll select a random point here. Make sure the tangent symbol appears on one of the ends and click. So we have a tangent constraint on this end. So I'm going to select the curve and this curve and add the tangential constraint on this end as well. After that, I can move it around and I can leave it where I feel the transition is much better. And I'm going to do the same thing here. Let me select a random point here and then a random point here. And once the tangent symbol appears on one end, I'll click it there, and I'm going to put the tangent constraint on the other end as well. So once that's done, let's take the trim tool and we'll trim the extra lines off. Make sure the lines are continuous. Hit finish sketch, and we see that the transition now is much more better than how it used to be. So that will be a final R hand. So I'll save it. Now to make the dial, I'm going to reuse the same thing, the same file. So this will be final. The R hand is final. So I'm going to just save a copy of this thing. So save as, and I'm going to create a file named FIB underscore dial. So this will be my dial. So you see that the file name has now changed. So this is a copy of the R hand file. I'm going to use this itself. So here I'm going to delete the extrude. First make sure you have the copy, because that R hand what we have done, that should be there. So this will be a copy of that, and this will be the dial. So I'll delete the extrude what we have done. So I'm left with only this curve, and once we have this curve, I'm just going to double click on the same curve, and here I'm going to draw the outline rectangle of the dial what we had done before. So I'll take the rectangle tool again from center, and then I'll select the origin here, and I'm going to draw a rectangle. So the dimensions of this rectangle we have already discussed it to be 250 by 100. So we see that the spiral fits pretty decently onto this dimensions of the dial. So once we are done with this, what I'm going to do is I'm going to draw one more line from the top center to the bottom edge center. So this will be my kind of the center line. I'll convert that into a reference. And after that, now if we see most of the clocks which are available, the Fibonacci clocks which are available, the 1 o'clock position is with the curve upwards like this. So probably you can take your own approach. So I'm just going to keep that as a reference. So I'm going to select this whole curve, make sure nothing else is selected, just this curve, and then I'm going to click this move curve tool, and I'm going to specify the pivot point as the center here. So the rotation will happen around this pivot point, and in the angle field, first of all I'm just going to align it based on a bit of trial and error. So I think I'll go with 270 degrees. This will be my first point. So I'll take this as the 1 o'clock position. I think I'll go ahead with this. So I'll take this as my 1 o'clock position, or I'll just 180. Okay, 180 will be a bit too high, and 270 I feel it's good. If there's a middle ground between the two, I'll probably go for that. Okay, I think I'll try 225. 225. I think I'll have enough space for 6 markings here. So this is a bit of a trial and error. We'll just have to be a bit careful with that. So I think I'll go ahead with 225, and the first position should be fixed properly. Make sure I have enough space above and below for the markings. So this I'll take this as my first marking for the 1 o'clock. So I'll select this arc by 3 points. And let's not bother about the width because I'm going to trim it later. So I'll select 1 point here, 1 point here, and then at the center I'm going to align it to this intersection. So this way, not align exactly tangential to this curve, it may or it may not. So that we'll try to get it as close as possible to that curve, but just don't worry if it doesn't align, because this curve is not exactly a proper curve, we can say. It doesn't have the same radius throughout. So this will be my 1 o'clock marking, and after that I'll select the whole thing again, but this time I'll have to deselect the curve that I just drew. So I'll deselect that, and I'll take the same move command, specify the pivot point as this point, and in the angle field now the clock usually it's circular, so we have in a circle we have 360 degrees, and on the clock we have 12 markings, 1 o'clock to 12 o'clock. So that will mean between each marking there is a 30-degree angle. So between say 1 o'clock and 2 o'clock there is a 30-degree angle. So that will be the angular deviation between each markings. So I'll give 30 degree as the value here, but make sure that the rotation happens in the clockwise direction. So let's see. The rotation here is in the anti-clockwise direction if we give 30 degrees. So I'm going to give minus 30, and we see that the rotation happened in the clockwise direction. So let's go ahead with this, and you see this original curve has remained in its place, and I'm going to draw one more curve in a very similar fashion. I'm going to click this point, the intersection. So the reason why I'm using intersection as the reference here is because that is the most precise point on which we'll read the time. So I'm going to keep that as a reference for each marking. So I'm going to select the whole curve again and deselect our previous 2 markings. Make sure you're not deselecting anything else but only that. So if you have a confusion, deselect this curve too, and then make sure this is deselected, and then you can anyway select this curve again. So I'll go to this move, the move curve command, and then specify the pivot point as this point. Give the angle as minus 30 degrees, and I'm going to draw a curve here. And at this point I'm going to see here the curve doesn't align exactly with this, so that is fine. So that's why I'm just keeping this point as the reference, so it should align here. Okay, so in the same way I'm going to do 3 more markings here and then 6 markings here. So after I finish the 3 markings here, let's see how we're going to go with the bottom markings. Now I have completed a total of 5 markings here. I am at my 5th marking. Now I have to go for the 6th one, but here I ran into a problem. So if I go for the move curve and then and select the pivot point as this point and give an angle of minus 30 degrees, you see that the center line no longer intersects inside the dimensions of the dial. So that is an issue. So this will be our last marking. So this will have to be a 6 o'clock marking. So instead of just redoing everything, what I'm going to do is I'll first see if everything aligns. Now at 0 it's aligning with the last marking what we made. If I give plus 30, it's going to align with our marking before that. 60 with this, 90 with this. This is how the clock is going to work anyway. And then 120 with this. So this initially we assume this to be our 1 o'clock marking, but instead what I'm going to do is I'm going to add 30 to this, so 150. So this, let's make this as a 1 o'clock marking. So if this is the 1 o'clock marking, then this will be 2, 3, 4, 5, and what we had done previously, that will be a 6 o'clock marking. So I'll get the curve here and I'll draw an arc intersecting the center. So we now have 1, 2, 3, 4, 5 and 6 markings on this end. So now what I'm going to do is I'm going to select the whole curve again. Just make sure deselecting all the other things other than the curve, including the marking that we just made. So this now is our 1 o'clock marking, just to make sure you're not confused there. This will be our 1 o'clock marking. I'm going to select the pivot point, and now here we have 6 positions, that is 6 o'clock till the 6 o'clock. So 6 into 30 will give me 180 degrees. So if I give 180, sorry, I think I just got a bit confused there. If I give okay, yeah, so minus 150, that should align us with the 6 o'clock position. So from 1 o'clock to 6 o'clock we can simulate in this way. We're at the 6 o'clock position now, and from the 6 o'clock position the next rotation will be another minus 30 degrees, so that will be minus 180. So again, we don't have any space here. We have 6 markings here already, and I don't want to add any more markings on this end. So what I'm going to do is I'm going to add markings here right now. So I'll hit OK, and then I'll create a curve on this end. So this will be my 7 o'clock marking. So this will be my 7 o'clock marking. Select everything again and deselect what is not needed. And go to this move curve, specify the pivot point and give minus 30 degrees. Oh, sorry, that is distance. So angle as minus 30 degrees. And once we get that, we can make another curve here. So you can see that I'm avoiding all these kinds of endpoints because I don't want to create any kind of a constraints which will be a headache once I try to move this again. So in this way, I have created 2 markings, and I'll create 4 more markings on this end. Okay, so with this line I have completed all the 12 markings. So we'll just count it once. 1, 2, 3, 4, 5, 6, and 7, 8, 9, 10, 11, and 12 right here. So we can continue in this same sketch itself, but I'm going to make a new sketch on top of this for my next step. So I'll hit finish, and first I'll save this. So once that is done, let's just make a new sketch here. So I'll just show the coordinate system, go to home, and we'll create a sketch on top of this. And once I have this, I'm going to make a rectangle which is same in dimension to what I've discussed previously. Okay, so I'll start from the center itself. And make sure the dimensions are right. So this is going to be 100. This should be, okay, that should have been, yeah, that should have been 270. So I think I've made a mistake there. That's fine. So I'll just make it 270 now. Okay, 250. I wanted to have some margin of error here, so that's why I kept 270, but I've given the input as 250, so that's fine. Anyway, this will be a final outline, so I'll make that as 100 by 270. Okay, so once that is done, the next thing what I'm going to do is I'm going to have to make all these curves. So before that, I'll draw the center line from the top edge center to the bottom edge center, and I'll convert this into a reference line. Okay, convert to reference. Once that is done, I'm going to trace all these curves onto this particular sketch. So as I said, you could have done all this work on the previous sketch itself, but I find this to be a better way so that there is no more issues with respect to the constraints. So I'm using arc by 3 points, and I'm making sure that it's tangential to the arcs on the sketch below. That will come out properly. Okay, so that creates all the 12 curves. So what I'm going to do now is I'm going to hide the sketch behind so that we have a better representation of what we are working with. I'm also going to hide the coordinate system. So we have the curves right here. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 curves in total. So that's what we needed. And when we made these curves, we didn't really bother about the width of this curve, so we are going to correct that now. So I'm going to draw a couple of vertical lines. One will be here. Make sure it's perfectly vertical, and the other will be here. Okay, so once that is done, let's just make sure these are vertical. Okay, this is already vertical. Yeah, and we're going to give them some dimensions. The overall width of this curve should be constrained between these two lines. So let's give them some particular width. So I think I'll give them say 20 mm on either end. Okay, so there is some constraint. So I think So here it has taken tangential constraint. I'm going to delete that. So this will be our final dimension of the limits of these curves. So let's make sure all the curves are intersecting the two lines. Yeah, but here these four curves are not. So what I'm going to do is I'm going to quick extend. That is fetching. So I'll make that touch the curve. This, and this. Okay. So now I'm going to convert these two curves into reference lines. Lines into reference lines, and I'm going to take the quick trim, and I'm going to trim all the excess portion that is sticking out from these two lines. So these three things we've already extended them to these lines, so there will be nothing else to trim. And here I can go on clean sweep. Okay, and once I come here, I can do the same thing. Here I can do the same thing. So now we have all the curves in the same limits between these 20 mm lines. So once that is done, we have to give them some kind of a thickness. So before that, what the other thing that I want to do is I want the numerals to be in between these. So for that, I'm going to again cut the curve at two more lines. So for this, I'll draw two more vertical lines. Make sure it has a vertical constraint. And we'll give it some dimensions. So here I have taken 20 mm, and here I can give a smaller value, say 10 mm, or probably less than that. So I think I'll go with say 8 mm. So 8 mm on either end, and I'm going to convert these two lines into reference again, and I'm going to trim the portions in between these two lines. Probably I think 8 mm is also a bit too much, so I think I'll go ahead with 5 mm on either end, or maybe 6. So here I'm going mostly on trial and error on most of the aspects, so probably you can make multiple attempts and refine your design. So whatever is there in between these two lines, I'm going to trim it. Sure you're not trimming the reference lines itself. So with that done, we have our curves and we have a space in between where we can write the numbers. And with that, I'm just going to offset these two lines onto either ends and create a kind of a thickness to them. So I'll take the offset command, and I'll use say 1 mm, so that will give me a total thickness of 2 mm. I'll make sure that the symmetrical offset is on, and convert input curves to reference is on, and I'll select these curves. I'll select all the curves together because they will all have the same thickness. So 6 on this end and 6 on the other end. hit OK. And the next step, what I have to do is to close this curve. So you can see that they have open edges. So for that, I'm just going to close those curves quickly. So you can probably trim them to this line and close them with straight lines as well, but I'm just going ahead with the same orientation as the curve is in. So first close the inner edges of all the curves. And on the bottom edge as well. And before I go to the bottom edge, I think I'll show how I'm going to close this end of the curve, the left end of it and the rightmost end of it. So I'm going to close that with a circular arc. So I'm going to take arc by center and I'll select this as the center and I'll draw an arc. So this is kind of a repetitive work, so I think I'll skip it and I'll show it at the end. So I have now created the flat edges on one side and the curved edges on the other side for all these set of lines. So as I said, it's repetitive work, so I'll skip that part. And the most complicated part is now over. So I'll hit finish sketch and we can see how it looks. So now the thing that we need, the end result that we need from all the work we're doing on an XCAD is a 2D drawing that we can take a printout of and cut it out on a cardboard and then assemble the clock. But I'm going to make it in 3D just so that we can have a better visualization and check it before we can actually assemble it in real. So there's one more thing I'd like to do here before I go any further. I'm going to add a circle at the center, which will be the hole that we have to cut out to fit the clock movement on the rear end. And we have these things that stick out, the posts onto which the hour, minute and the seconds hand fit. So for that we need a hole. So for this hole I'm going to keep the dimension at 6 millimeters because the outer diameter of the post on the clock moment is 5.5 millimeters. So I'm just going to keep some clearance and keep it 6 millimeters. Anyway, such small holes, it's difficult to cut it precisely, so we can have some margin of error there. So once that is done, as I said, I'm going to make it in 3D. So I'll click the sketch and then I'll go to home and click on extrude, and I'm going to give some value, say 2 millimeters, and I'm going to extrude this. So now we have okay, there is one curve missing here. Let's see why that is not coming up. There is some issue here and we have to see what that is. Okay, so I guess one of these ends is not connected, probably this end. Yeah. So I'm just going to probably use trim corner. Yeah, that should solve it. Yeah, now so we have all the cutouts now, and once this is ready, I can hide the sketch. And we can see how the movement looks. So we have it still looks kind of done. So we have a few more additions what we can do on this. One thing is I want to make few indices here for the minute and the seconds hand. The other thing is I want to add numbers between these, so that we're going to do it now. So before that, I'm just going to add small fillets on the top end for it to make it look a bit nicer. I think I'll give a value of say 10 millimeters or say 15. But at the bottom end, I'm just going to leave it sharp because I want to create a kind of support at the base. So this is how the dial is going to look. And on top of this, we have to add the numbers. So 1, 2, 3, 4, 5, 6 here, 7, 8, 9, 10, 11, 12 here. So we'll do that. Now, at this point, I felt the width of 20 mm what I gave for these curves. That was not sufficient. So I've increased that to 25. The advantage of using these parametric CAD modeling softwares is that we can vary these values at any time, and we can make modifications and keep trying different dimensions. So I did have some issues with the connectivity with some of these edges, but I was able to just correct those. And with that, I feel the curves look much better. I hit finish and I'll hide the sketch. So you can see now the width looks much better compared to what we had before. So the next step is to add numerals in the gap that we left in the middle. So for that, first I'll have to create a sketch, and in this sketch I'll have to draw connecting curves between these. So I'll take this as the first point, this is the second point, and make sure there's a tangential constraint and click. And I'll do the same thing to each of those. I'm having some trouble here. So that's tangential. Okay, I'll come back to that. Okay, so in that case, what I can try to do is I'll just pick these two extreme edges. I'll go to curve again. I'll pick these two extreme edges and try to make it tangential here, and then I'll do the same thing to all these curves where I'm having problems. Sorry. So I'll take this edge, make it tangential. Same thing here. And what I'm going to do is I'm just going to draw a kind of a straight line here, because they're all supposed to be on the same point. I'll have to select the bottom corner. So that is not going to work. So individually what I'm going to do is I'm just going to draw a line from this point, just a random line, and I can use the trim tool to trim it till that point and then delete that line. So in the same way I can do it to the other corners as well. Just a random line, it doesn't matter, the orientation of the line doesn't matter. So now what we can do is we can take the trim tool and trim the excess lines, and we'll delete the reference lines as well. Now in the same way I have to make those curves here as well. So since I'm considering the bottom of the lines as the reference here, I'm going to take this top as the reference, kind of like a mirror image. Okay, so one line is one of these is missing. We'll have to see what is causing that. So we have all the curves, but we have this missing here, and let's just see what is causing that and troubleshoot it. So if we go here, yeah, so there is this very small gap here. We can use the make corner, and we create a corner there. That should be fine. So now I'll go back and I'll hide this sketch. I'll go back into this and create a curve here. Now all this work, the complexity of this work can be reduced compared to what I'm doing here, but I'm just making sure that it's not clumsy. It's easy to edit or make. Okay, that's not right. So again, I'll just select these 2 points and create a curve between those two. Create 2 random lines from these endpoints. Then trim the line. And delete the reference lines. So with that, we have added all the lines that we need as our reference for including the numerals. So we'll go for adding the numerals itself. So I'll go for the curve tab and we have the text option here. I'll select that. So the first thing, it will be usually in planar, so I'll have to select on face and then I'll have to select this face. After that, I have to select the curve. So I'll click on select curve, then select this particular curve, and we have the number flipped here, so I'll flip it using this button, and then I can adjust it to wherever I want. I'd like to keep this value as 50%. The reason why I trimmed it exactly at these 2 points is that I can keep it at 50. Okay, 50 is too much, so I'll keep it at 45%. That's somewhat good. Yeah, so I'll keep it at nearly 45%. And then we'll put the number what we want here. So I'll go in the same order. So first we want 1 here. I'll add that, and we can also adjust the height and the width of it. So the length I'll keep it as say 2.5, the height as 5. Okay, so I feel that that is an okay number, and I'll hit OK. In the same way, I'll take text again, on face, I'll select this face, then I'll select this curve, and you can already see the number appearing here. So instead of 1, I'll hit 2. So again, I can make some modifications. So I think, yeah, the alignment is nearly the same. Okay, I'll go with 45 itself or 46. And probably we can reduce the width. Okay, that is the length. Yeah. So in the same way, I'll have to create all these numbers. So I'll skip that step and I'll create all the numbers. Now I have almost finished adding all the numbers except 12, and I've made some modifications along the way. The first thing is that the curves which I had put on the top here, I've deleted them and I've put the curves on the bottom, because in a way the number sits on the particular curves that we are putting as reference. For that reason, I put the curves on the bottom end. And the other thing is, while adding the numbers, I've made sure that I've placed them in the middle. There's an option to place it in the middle and show it in the last number. And I've given kind of an increasing size of font, and I've tried to mirror the same thing on the other end. So the other number that is remaining is 12. So we'll add 12 on face, we'll select this face, we'll select this curve, and we can just move it around, and we'll see that at one point the midpoint symbol appears. And since we have trimmed the curve between these two ends, this will be the proper midpoint. And after that, I'll click on this and we can edit the sizes. So I have listed down the sizes what I have used on the other end. The height will be 10, and the length, well, on the other end it is 7.5, but that is for a single digit. So here we'll keep it something in a reasonable range, so it's 12, so we'll keep it at say 10 or 11. Yeah, I think I'll go with 11.5. So something which looks reasonable on this end. So that finishes all the numbers. So we have 1, 2, 3, 4, 5, 6 and 7, 8, 9, 10, 11, 12. So I think I can increase the height of 5 a little bit comparatively. 3 to 10. This height I can increase it to 11. So I will do the same thing here. So that looks much more better, I feel. This height I can make it 10. This height I'll make it 11. Okay, so I feel that looks better. So once all this is done, we'll have to extrude them. So I'll have to select one character after the other. I can take any order and just extrude it. So I'm just going to cut it completely because anyway I need a 3D sketch. So I'm just going to select each of these and use subtract option in the boolean and just hit OK. So we can see there's a proper cutout here. So in the same way I'll do it for everything. So don't worry, there is an isolated piece here, so we don't have to worry about that. We need it. So I'll select it. I'll see if I can select everything together. Select this as the main body. Yeah, that works. Okay, in the same way I'll do it for all these numbers as well. Now we have all these numbers, so I'll hide all the text in the background and I just have the cutouts here. I'll hide the sketch as well, so we just have the numbers. Okay, I've somehow missed 12, I think. Yeah. For some reason the 12 didn't cut out, so just check. I missed one, so this as well. And 12 looks a bit too close to this curve. Okay, that's fine. Anyway, we're not going to cut it. I'll try to align it, but I think it's already on the midpoint. Yeah, it's already on the midpoint. Okay, so with that done, our clock dial is mostly complete. And the next step that I am planning to do is to make kind of a dial with indices here, just for the minutes and the seconds hand. So we'll do that. Now this is not absolutely required, but I just felt it would be nice to have some kind of a very small dial here for the minute and the seconds hand, which shows the indices for the hours and minutes. So this is optional, so this may be skipped, but I don't like the empty space here. For that reason I'm doing this. So for that what I'm going to do is I'll take sketch and I'll choose this face, and here I'm going to draw a circle. So keeping this same center, let me switch that on. Keeping the same center, I'll draw a circle. So I think I can fit say a 65 mm circle here. So I have fit a 65 mm circle here, and once I have the circle I can draw the indices. So I'm going only for the major markers, that is 12, 1, 2, like that, so on. So I'll draw one in the 12 o'clock position. For that I'll draw a reference line from the center to the, I'll switch these quadrant points on, so to this point. And I'll convert these as reference. And I'll just draw a rectangle here. And I'll keep the dimensions on both ends equal. So I'll just make this as 1 millimeter, so that I can give 0.5 millimeters on either end. length of say 2 millimeters. Let's, sorry, not 20, 2 millimeters. Probably I think I can go for a bit more. Probably. Yeah, I think I'll settle with 4 millimeters. And once I have one such thing ready, I can just rotate it around. I can make a pattern, a circular pattern. So I'll select the pattern curve and I'll go for a circular pattern. I'll need 12 such counts, so it's already in 12, and the pitch angle will be 30 degrees as we have calculated earlier, and the rotation point will be the center, and the curve itself I'll have to select. So just select the 4 lines. Yeah, everything is selected, and yeah, now we can see that at all the intervals 1, 2, 3, 4 and so on, we have these boxes. So I'll hit OK. That is good. So once we have this, I'll just make larger boxes at the 12, 3, 6 and 9 positions. So for that, what I'm going to do is I'm going to take the same approach. So 1 point here, 1 point here, and I'll draw it till here, and the width I'll keep it a bit larger than 1 millimeter. So say let's go for 3 millimeters, so that I can distribute it as 1.5 millimeters on either end. And the length itself, let's say go for 6 millimeters. Say a bit more, 8 millimeters. Yeah, I'll go for 8 millimeters, but I'll reduce this 3 millimeters to say 2 millimeters. Just to 1. Yeah. So I feel that is better, but I'm planning to add a bit of a taper to this end. For that, I'll take the chamfer option, and instead of the symmetric chamfer, I'll go for the asymmetric one. So okay, that didn't come out right. So I'll go for chamfer again. Asymmetric is selected. So on one end I'll take the whole 8 millimeters. On the other I'll go for we have 1 mm here, so I'll go for 0.6 mm. Yeah, so this is how I want it to be. In the same way, I'm going to select these 2 edges as well. Okay, and I think we have extra lines here. I'll just convert that as reference lines, and yeah, we can come to that again. And make sure these edges are connected. So I'll just in any case I'll just make corner between these 2 lines. Okay, so that's over constraint, so it's already connected. So what we're going to do is we're going to do a pattern again. So I'll go for the pattern, circular pattern, and I'll specify the rotation point as this one. The count will be 4 and the pitch angle will be 90 degrees. And the curve itself you'll have to select. So this will be the curve that I'll be selecting. Okay, so these edges are also connected. So I think I'll just go to single curve instead and deselect these edges. And we can see that it's being created at these points. So now we don't need the one that is on the inside, so we'll just convert that into a reference. same way we can convert all these into references as well. And our dial should be ready. Let's hit finish, and if everything has gone right, once I extrude it, I should get a proper cutout here. So I'll select this as the body. Let's see. Make sure all the cutouts have come up. Yeah. So that is how I wanted it to be. So I'll hide the sketch. So this is how it is going to look. Now with that complete, our dial is mostly ready, but I'd like to add a bit of a personal touch or kind of a customized touch. You can probably skip this, you can delete this when you print out the pattern, but just for my sake I'm just adding this. So I'll draw a small line here. Fine. It's 10 mm. So that this thing is centered. And I'll take text, and you might have guessed it, I'm just adding my initials. I'll select this face, I'll select this curve, and US is what I'm going to add. This will include my name as well as my parents' name. I'm just going to give a suitable dimension for this. Hide the sketch, and I'm just going to cut this out. Subtract it from this body and hide the sketch as well. So that is our finished dial. Now we have to make the support for this next. We'll come to that. So the dial is ready.